Welcome to my lesson today, Creoles Boys High School, Marida James. We are discussing Form 3, Organic Chemistry 1, revision exercise. Welcome as I go through the questions, as I analyze and summarize the flowchart. Hope you will enjoy. In the diagram question number 3, in the revision question, study the reaction scheme below and answer the question that follows. We have ethanol reacting with the sulfuric acid in step 1 with a condition of 160 to 180. Then you get a colorless gas A. The colorless gas A is reacted with oxygen heat. Then you have gas D and then liquid E. So the same gas A is reacted with hydrogen chloride, then you have product P. Then from gas A you have, in this step where we have this gas A, then we have an ethane. We are supposed to name a colorless gas A, product P, gas D, and a liquid E. Write a balanced equations for each of the reactions forming the product in above. Then name the type of a reaction taking place in step 1 and 2. State the importance of the reaction taking place in step 3. First of all, let us look at this flowchart. In step 1, we have the preparation. Step 1, it is testing the laboratory preparation of alkene. In a laboratory preparation of alkenes, alkenes are prepared from a dehydrating of alkanols. In this case, an alkanol here is ethanol, so we are using a concentrated sulfuric acid to remove the water element. Dehydration is removal of water element. We have normally two reagents which can be used to dehydrate. So in this step 1, we either use the concentrated sulfuric acid. So we are using this one as a conc sulfuric acid in this case to dehydrate this ethanol, or you can use the aluminum oxide. You can also use here the aluminum. You use the aluminum oxide. So if you take, for example, if you take an alkanol, and then you pass the conc sulfuric acid, the concentrated sulfuric acid will remove the water element, and then you will be having an alkene. Then plus water. So you can also use the aluminum oxide. So if we have an alkanol, then in this case you dehydrate using the aluminum oxide, you will get an alkene. Then plus you will be getting an alkene plus water. So at about 180 or 160 degrees, concentrated sulfuric acid dehydrates or removes water from ethanol to form ethene. So what is happening here, you will be having, and this is step 1, in step 1, you will be having at about 160 to 180 or 180, so you can have the ethanol, which is the formula of ethanol is like this: C2H5, so we have OH. This one is in a liquid form. So if we are using the conc sulfuric acid, concentrated sulfuric acid as a dehydrating agent, so it will form an alkene. And in this case, alkene, we can have ethene. You have this one here, then plus, so we plus water. So our colorless gas A is just ethene. So we have colorless gas A as ethene, which is CH2, then we have CH2. You can also be drawing a structure of this one. So you have carbon, hydrogen, and nitrogen. So we draw the structure of that gas A. Now we proceed. So the process here in this is step 1, whereby the sulfuric acid is removing the water elements. This one here is dehydration. So we have the dehydration. Sulfuric acid removes the water and the water elements from a compound. Now we have this colorless gas A, then you are passing the gas, you are heating the gas in the presence of oxygen. You will be getting gas D, and then we have liquid E. This part, it is testing the chemical properties of alkenes, and the chemical properties of alkenes tested here is panning or combustion. So here we can have panning. You have this one as panning, or you can have this one as combustion. So what is happening that if you will be having an alkene, you will be having an alkene plus air, you will get carbon dioxide and water. So all the compounds containing carbon, when you pan in the presence of air, you will get CO2 and water. So alkenes in this case, which is discussed now, an alkene will pan in excess oxygen. So if we introduce an excess oxygen here, we will form carbon dioxide and water. So in that gas now, we can have this one as a C2, carbon 2, then we have 4 hydrogens. This is a gas. Then we are panning in excess oxygen. In excess oxygen, you will be getting CO2, so you will have this one as a CO2 gas, then plus water. So you have this CO2 plus water. So you have a CO2 gas plus water. So this one here we are talking now, this oxygen here, it is excess. So we have an excess oxygen there. But if you pan in a limited, so if you can pan, this one is in a limited air. So if you pan this one is in a limited air, you will get carbon monoxide. So you have this one is carbon monoxide, and then we have water. So in this case, we have a limited. So we talk of a limited air. So the product gas D and liquid E. So in this case here, we are using our excess oxygen. So our gas D is just carbon dioxide. So we have, this is a carbon 4. We have this one as carbon dioxide. And then liquid E is just water. Now we have in step 3, in this step 3, we have a colorless gas A, which is our ethene now, reacting with a hydrogen chloride. So what is happening here that this reaction, the reaction in step 3, we call it hydrohalogenation, the hydrohalogenation. So in that case, we can have that in this is step 3, where we have that gas, we can have this gas as CH2. Then we have CH2. This one here, we are reacting with chlorine. So if you react this one with chlorine, if you react this one with HCl, which is a chlorine here, so what product will you have? So if you can have, you can open the structure of that. So you can open the structure of that hydrogen, then we have an hydrogen here, hydrogen there. This one is now reacting with chlorine. So you can have chlorine, hydrogen chloride. So what you will get, remember this one is unsaturated hydrocarbon. So this one is unsaturated. Unsaturated unsaturated hydrocarbon, it means it has this one. It has a double bond. This one, it has a double bond. It has a double bonds between carbon to carbon atoms. So what will happen here when you the process of halogenation, the hydrogen, the halogens will just react. What will happen here? The hydrogen chloride gas will be decaralized in this case, and then you will have the one hydrogen. This one bond will just disappear, so you will be having a single bond there. The chlorine molecule will just have it there, and then for carbon atoms to be complete, it must have a maximum of 4 bonds. So we have an hydrogen there, an hydrogen here, an hydrogen here, hydrogen there, hydrogen there. So the name of this compound is called chlor. So we have, this is a chlor ethane. So we have this one as chlor ethane, which is our product P. So this product P, this one here, it is a chloroethane, correct? Then we have in step 2, where we have a colorless gas A reacting in step 3, then we can have ethane gas. So it is from ethene to ethane. What is happening here? This step is called hydrogenation. This is hydrogenation. The hydrogenation, it is an addition in which a saturated compound reacts to form a saturated compound. So in this case here, you have, this is a saturated compound. So we have ethane, which is a C2. Then we have C2. On the other side now we can have CH3. Then we have, this is a CH3. So this, we can have this one as ethene, and this one is ethane. This one, as I said earlier, this one is saturated. This one is saturated, and this one is unsaturated. When you talk about unsaturated, it means it has a single bond. I mean, when you talk of saturated, it means this one we have a single bond between carbon atoms, and saturated we have a double bond between the carbon atoms. So a reaction in which unsaturated compound react to form a saturated compound is called hydrogenation. So this reaction, we can call it hydrogenation, which is in that step. So that is all you can have about this diagram. So again, in this hydrogenation, hydrogenation is addition reaction in which a hydrogen react with alkenes to form a corresponding alkanes. In this case, it can react with ethene, which is an unsaturated compound, to form ethane, which is a saturated compound. Now, what are the conditions for this reaction? The conditions here for this reaction in this step, the conditions for hydrogenation, one, you have a temperature. So you can have, you have temperature here, and this temperature is between 150 to 250. You can also use palladium. So we have the palladium catalyst, or you can use technical catalyst. Then you also have a pressure. So you can have a pressure which is ranging between 200 to 250 atmosphere. And then the reagent, of course, you can have a reagent. A reagent is hydrogen. So you can have this one as the reagent here, it is hydrogen. So So somebody you will be writing when you asked now state the conditions required in this step. And if you write high temperature, you cannot score. So high temperature cannot be scored. So if a candidate writes high temperature, there is no score. So you can't score this one here. You need to mention a temperature which is between 150 to 200. And in this case, a candidate is not supposed to give the range. You just give a value ranging between 150 to 200. It can be 150, it can be 200, it can be 180, but you are not supposed to give the range. And again, if you write high temperature, there is no score. Then now, when hydrogen is passed through a liquid vegetable, this hydrogen now, when it is passed through the liquid vegetable and animal oil. So we can have now the industrial importance of this step, that when hydrogen gas is passed, when hydrogen gas is passed through liquid vegetable and animal oil. At about 200 in presence of either palladium or a nickel catalyst. So you can talk of this one as palladium or a nickel or the nickel catalyst. Solid fat is formed. The solid fat is formed. Now this hydrogen now, it is used to harden. Hydrogenation is used now to harden oils to fat. So the importance of this hydrogenation is used to harden oils to solid fat, especially in manufacture of margarine. So it is wrong to say that hydrogenation is used in the manufacture of margarine. It is very, very wrong to say that hydrogenation is used in the manufacture of margarine. Hydrogenation is not used in the manufacture of margarine. It is used to harden. The oils to solid fat, especially in the manufacture of margarine. So those students and the candidates who write that hydrogenation is used in the manufacture of margarine, that one is wrong. You just say hydrogenation is used to harden oils to solid fat, especially in the manufacture of margarine. Correct. So in this flowchart, you were supposed to name colorless gas A. So colorless gas A is ethene gas, product P is chloroethane, gas D is carbon dioxide gas, then liquid A is water. Write a balanced equation for the reaction forming the product in the above. Of course, you can follow this one here. So in the first case, we have ethanol, which is in the step 1, where we have ethene plus water. And the second case now, we are taking a colorless, which is ethene in the presence of oxygen. In this case, we are using excess oxygen. So you will be getting the ethene plus excess oxygen, you get carbon dioxide and water. And then this product P, hopefully I have done it somewhere here. So where you write the equation of the reaction that can produce ethene gas, ethene gas to ethane. Name the type of reaction taking place in step 1 and step 2. So in step one, the type of reaction taking place there, it is dehydration. So in that step we have dehydration. So that step we have it is dehydration. Then in step 2, we say that this one, step 2 is where we have, step 2 is hydrogenation. Step 2 is, we have this one as hydrogenation. Then state the importance of the reaction taking place in step 2. This is this one here. The importance of this hydrogenation. So you just say that the importance of that one, hydrogenation is used to harden. Hydrogenation is used to harden oils to solid fat, especially in the manufacture of margarine. I repeat again that it is wrong to say that it is used in the manufacture of margarine. No, it is used to harden oils to solid fat, especially in the manufacture of margarine. Keep on following my channel as I keeping on revising the questions on flowcharts. Marita James, Grigors Boys High School. Kindly subscribe. Click the notification bell. You get notified once I upload a new video.